molality. Molality is denoted by small m, and that m is equal to number of mole of solute to the mass of solvent in kg. Mass of solvent in kg. So here again number of mole, we have mass of solute to the molar mass of solute to the mass of solvent in kg. This is calculated molality. Then a new parameter, that is mole fraction. Mole fraction. Mole fraction, as we know, is denoted by chi. It is similar to x, that is chi. So mole fraction of solute is equal to number of mole of solute to the number of mole of solute plus number of mole of solvent. Similarly, here mole fraction of solvent. So we have number of mole of solvent to the number of mole of solute plus number of mole of solvent. So here mole fraction of solute plus mole fraction of solvent is always 1. Mole fraction of solute and mole fraction of solvent is always 1. In this way the mole fraction is calculated. Clear? Next parameter, that is ppm, parts per million. It is a very small unit. So this ppm is always calculated in a percentage. So ppm, parts per million of solute, is calculated by mass of solute to the mass of solution into 100, because it is always calculated in a percentage, because it is very small unit, very small, that is it can be negligible with respect to that solution, or you can say solvent, so that it is named as parts per million. And we know that parts per million means its power is 10 to the power 6. So here parts per million, mass of solute to the mass of solution into 100, that is a percentage, and million, that is 10 to the power 6. So in this way we will calculate ppm, parts per million. And also some term used in terms of normality, that is normal is said to be, when we said normal, that is n. If we said decinormal, that is normality is 1 by 10. If we said centinormal, that is n by 100. If we said semi-normal, that is n by 2. If we said binormal, that is its normality is 2. Similarly, here we will discuss with the molarity also, in terms of molarity, semi-molar, decimolar, centimolar, all that things. Here commonly used molarity term, commonly used molarity term, or you can say normality term, both. So molar, its molarity is 1. Then deci, its molarity is m by 10. Centi, its molarity is m by 100. Bimolar, its molarity is 2 molar solution. It is said to be molar, decimolar, centimolar, bimolar. In terms of normality, it is said to be normality, decinormal, centinormal, and binormal. Clear? This is the representation, and it is also represented as 1 Here 1 by 10, here 1 upon 100 for centi, here 2 molar. These commonly used molarity term. मोलर को हम कहते हैं 1, डेसी मोलर 1 by 10, सेंटीमोलर 1 upon 100, बाई मोलर 2. So it is written as 1 mole per liter. Here also mole per liter. Here also mole per liter. Its unit mole per liter means 2 mole in 1 liter. 1 by 100 mole in 1 liter. 1 by 10 mole in liter. 1 mole in 1 liter. So that its molarity is 1. Similarly, in terms of normality also we will calculate this, and it is commonly used molar, decimolar, centimolar, bimolar. Decimolar 1 by 10, centimolar 1 upon 100, bimolar 2. Its molarity of solution is 2. Now here we will discuss, that is non-volatile non-electrolytic solute. Electrolytic solute. Non-volatile non-electrolytic solute and electrolytic solute, dissociation and association. Now, non-volatile non-electrolytic solution. So non-electrolytic solution means what? Here non-electrolytic solution, non-electrolytic solute. What do you mean by non-electrolytic solute? A solute which do not ionize in water, right? Solute which do not ionize in water, that is non-electrolytic solute. This non-electrolytic example sugar, urea and glucose, etc. Sugar, urea, glucose are non-electrolytic solute. Here then we will discuss electrolytic solute. Electrolytic solute. Here electrolytic solute means solute are two types. Electrolytic solute are two types. One or second. One is said to be strong electrolyte and second one is weak electrolyte. Strong electrolyte, that is ionizable completely. Strong electrolyte which completely ionize or which completely dissociate in water. For example, say NaCl, KCl, KBr, ammonium chloride and potassium sulfate, etc. are the strong electrolyte. On aqueous solution, it dissociate into their ion in this way. NaCl complete dissociate to give Na plus and Cl minus. Similarly, K2SO4 gives 2K plus and SO4 2 minus. This is the strong electrolyte. But in case of weak electrolyte which partially ionized, which do not completely ionize, which is partially ionized, like CH3COOH, NH4OH, weak base and weak acid, and HCN, hydrogen cyanide, etc. are the weak electrolyte which dissociate complete, which ionize partially, which cannot dissociate completely. Now next topic, that is dissociation. Dissociation, or it is also said to be ionization or ionize completely, means suppose that a solute which completely dissociate, that is said to be dissociation. For example, let's see NaCl. NaCl dissociate to give Na plus Cl minus. So here there is an interaction between NaCl is electrostatic. This electrostatic attraction between Na plus and Cl minus, when dissolved in water, it gives Na plus and Cl minus. So that is the dissociate, or that is a strong electrolyte also, right? In case of association, here suppose that we have a benzoic acid, right? Benzoic acid is dissolved in a benzene, right? In case of dissociation, water is a solvent. In case of association, benzoic acid dissolved in benzene. It undergoes dimerization to form dimer of benzoic acid. Example, C6H5COOH. 2 molecule of benzoic acid gives C6H5COOH twicely. This is dimeric form, means this undergoes 2 molecule of benzoic acid is associate to form such type of dimer. This is the dimer. This term dissociation and association we will discuss later on. That is, it is also depends on value I, that is want of factor, and we will discuss this part at the last of the chapter, so that, but we will hear only the term dissociation and association. What do you mean by that? We will discuss. Dissociation means dissociate into ion. Association means what? When organic compound dissolve in a solvent to form dimeric form, that is said to be association. We will discuss this part at the last.